All right, ladies and gentlemen, yesterday we started multiplying decimals by decimals using the hundredths grid. This was practice one. This was the introduction yesterday. So I never expect everyone to understand it fully during the first practice. So what I need is to make sure you guys realize that and realize we're going to go over it some more. We're going to keep practicing until we understand it. Kipton.
Are you making a video?
Yes.
Yay.
So we're going to keep practicing this until we understand it. I'm recording videos so you can watch them. They are on the Tube of You. So you can go there and watch them. Shut your computers. I don't want you to be distracted. All right, so we're going to do a couple problems. I'm going to talk through them. Listen as I talk. If you're stuck, go back and watch the videos again, or ask me and I can help you individually. I'm not even saying today at the end of the day you're going to understand it fully. Okay, but you got to give yourself a chance to learn it, a chance not to freak out if we don't get it. Okay, I was learning to ride a bike yesterday, and I didn't freak out just because I fell down and broke my skull open. My brains were all over the floor. It was horrible. But I did not do that. Okay, so you got to keep a positive attitude. And don't be afraid of difficult tasks. You can learn from your mistakes. Do your best. I don't get it yet. Yet is an important word. So we're going to keep going until we do get it. And if you stick with me, I can help you get it. So today I'm going to show you the grid. And then I'm going to show you the standard algorithm. The grid and then the standard algorithm. First problem we're going to do, 6/10 times 3/10. So follow along with me on your paper. 6/10 times 3/10. Now I want to ask a question. It's not directly related to this problem, so don't think in terms of this problem. But Jaden, what is 12 times 1?
12 times 1.
Okay? So if I multiply something by 1, it stays the same. Braden, what's 12 times 2?
24.
So if I multiply a number by something greater than 1, that number gets bigger. These numbers are smaller than 1. These numbers are smaller than 1, so my answer is going to get smaller. My product is going to get smaller than the factors that are listed. That's why you start off with 6/10, and each big square is one whole. So this thing here is one whole, is 1. Each column or each row is worth 1/10, 0.1. And each little square is worth how much? 100. So the little square is 100. The big long rows like this or like this are 1/10. The whole big thing is one whole. That's important to know because that messed some of you up yesterday on the assignment. It's not going in the grade book. I'm checking where we are. That's a status check. Yes, ma'am.
So the little squares are pennies pretty much?
Yeah, they're like pennies.
And then the rows are like
Dimes.
yeah.
So the whole thing would be like $1. Each row or each column would be like a dime. Each individual little box would be like a penny. All right. So the step 1 on doing this is we take the first number and you color in 6 rows or 6 columns, however you want to do it, but you should have 6/10 shaded in. That's 1/10 right there. You're going to do that 6 times. 2/10, 3/10, 4/10, 5/10, 6/10. How many little boxes do I have shaded in?
6.
No? Little boxes.
60.
60. I have 60 shaded in. So that's 6/10. 6/10 equals 60 hundredths. My second fraction is 3/10. 3/10. So I'm going to multiply across, or I'm going to shade in across. And I get 3/10. So I've shaded 6/10 in vertically. I've shaded 3/10 in horizontally. And your answer is the ones that are shaded up in by both colors. The answer is what you're shaded in by both colors. The little boxes that are shaded in by both colors. So since each little box I know equals 100th, I'm going to have to go 2 places behind my decimal point. Landon? 18 hundredths. 18 hundredths. Or 0 and 18 hundredths. Yes?
So when you said the number would be smaller, you would have to go 2 points behind the decimal. But if the number was bigger, would you do the same thing?
Well, if you're multiplying by 2 numbers less than 1, your answer is always going to be smaller.
Okay.
This right here is smaller than both 3/10 and 6/10. Because if I had to compare them, I'd have 1 in the 10th place. This one has 6 and this one has 3. Allie.
So this is a question of how if we can do something with this. Can we use colored pencils to this?
Yeah, certainly. Certainly. Let me show you one that about half of you got wrong yesterday. Okay? And when I gave it to you, I knew half of you would get it wrong yesterday. But again, it's me trying to find out what you know. Until I know what you know, I can't know how far I got to go to teach, right? If I think you don't know how to add, addie-o, then I got to go back to the beginning. I can't start at multiplication, right? So I know you know how to add. All right, so let's try 2/10 times 4/10. 2/10 times 4/10. So shade in on your paper.
Oh, I accidentally put down here.
I don't care where you put it. All right, so the first thing I'm going to do is I'm going to take 2/10. I'm going to shade in 2/10. And again, if you do it crossways, I don't care. As long as you have 2/10 shaded in, you're good. Then I'm going to take a different color. I'm going to shade in 4/10 the other direction. This one's horizontal. Then I have to look at what is shaded in both. Well, what is shaded in both is these right here are shaded in both. So how many little squares is that?
8.
8. Now what I saw yesterday is a lot of people put 0.8. That's not right. It's 8 hundredths. Because every one of these little squares is worth 100th. So the correct answer should be, because there are 8 little squares there. So it should be 8 hundredths. If it were 8/10, that would be 8 of these rows would be shaded in. Or 8 of these columns would be shaded in. But since it is not, then we know it is in the hundredths place. So how many ever little squares put up, you're going to have to put 2 digits behind the decimal point to go to the hundredths place. Landon.
Why does it go smaller?
Because I'm multiplying by something less than 1.
Yeah, but
Like Jaden told me, okay? we said 12 times 1 is 12, right? 12 times 2 is 24, right? So if I multiply a number by a bigger than 1, my number gets greater, right?
Oh, why does it get lower?
I know, I'm going through the whole explanation. So if I multiply a number by something greater than 1, it's going to get bigger. These are both less than 1. So if I multiply by 1, it stays the same. If I multiply by greater than 1, it gets bigger. If I multiply by less than 1, it gets smaller.
Oh, like 0. Multiplying by
Yes, just like multiplying by 0, it gets smaller. All right, now let's look at the standard algorithm. Okay, what was we do the you know the work you had for both of those. You know what the drawing looks like in your hundreds chart. So what was the first question, Braden?
Wait, like that we just wrote down or?
Yeah, the first one we did.
0.6 tenths times 3 tenths.
All right, when multiplying using the standard algorithm, the first thing you do is we count how many numbers are behind the decimal point in the problem. How many numbers are behind the decimal point in the problem?
2.
2. That means there has to be 2 numbers behind the decimal point in the answer. So once I know how many numbers are behind the decimal point in the problem, then I can just rewrite it without the decimal points. I solve 6 times 3 is what?
18.
18. How many numbers behind the decimal point in the problem?
2.
That's how many behind it in the answer. And we got the same thing as we got on the picture. The same thing we got on the picture. And the second problem was what?
2 times 4.
2 tenths times 4 tenths. How many numbers behind the decimal point in the problem? 2. So there has to be 2 behind it in the answer.
8.
And I have 2 times 4 is 8. I need 2 numbers behind the decimal point. I can't move that 8 over. I can't make it 80 and put 0.80 because then that equals 8 tenths. So if I put the decimal point in front of it, then it's 8 hundredths.
Let's go.
Just like we did on the paper. Just like you did on the picture. Yes, sir. Well, not quite by negative numbers, but really small numbers. Yes, sir.
What would you do with like 2 digits in the decimal for when you're multiplying it and trying to see how much there is?
All right. Well, let's look at one of those. Let's look at 2.14 times 0.7. I'm just making this up. Just relax. You just watch. Just watch. How many numbers are behind the decimal point in the problem? 3. 1, 2, 3. So now I multiply. I just take out the decimal point and multiply like normal. 214 times 7. And I multiply that. So 7 times 4 is 28. 8, 2, 7, 8, 9, 14. And how many numbers need to be behind the decimal point? 3. 1 and 498,000. Boom! Shakalaka, peace out. God bless. Love you. Do something kind today. Subscribe on YouTube to Keller GBBB. Keller GBBB.